Hello, hello, hello. Grüezi, grüezi. You all good? Welcome back from lunch. If anyone is still in food coma, it's my pleasure to wake you up. And I think the best way to do this is to tell you why I am excited for the next talk. The speaker is Vincent Sarago from Development Seed. Many of you probably know the name Development Seed. Mapbox was a spin-off of Development Seed. They've been around for 20 years. So I have a very strong prior on any technology coming from them being exciting, and I hope you do the same. Have fun, enjoy. Vincent.
Thank you. All right. So yeah, thanks everyone for being there just after lunch. I'll try to wake you up, I hope so, with the thing I'm going to present today. So I'm going to talk about dynamic tile server. And so as said, I'm a geospatial developer from Development Seed. I'm a self-taught Python dev, so many maybe here also taught themselves how to program in Python. I had a lot of luck having great mentors to teach me also sometimes better ways of programming and stuff. Yeah, basically, yeah, software developer at Development Seed. So first, I want to know who knows what is dynamic tile server here? Okay, 2, 3, okay. Who knows what a map tile is? Everyone knows what a map tile. When you go on Google Map, you see tiles coming up and showing things about what's on the ground. And so there are two different tiles. There are the raster tiles, so usually PNGs, JPEG, WebP. They are usually really small, 256 by 256 pixels. And there are the vector tiles that are bigger. They usually are encoded in PBF and MVG. And the difference between both of them is one is created on the backend, on the server. So the raster tile will it will be the colors, everything will be created on the server or before getting to the map client. While the vector tile, they just send you lines or polygons, and then you apply style on the client. So there are two different, really different things between map raster and vector tiles. And so on the right side, left side, sorry, that's the OSM background. It's usually served in raster tiles, so you can see the tiles getting loaded. And on the right side, yeah, it's a Strava-based map. They use a Mapbox. The tiles are vector tiles. The styling is applied on the client, so the client can almost choose what kind of color he wants the line to be in. So that's just to show the difference. And so the name of my presentation is about dynamic tiling, is because there are two ways of serving tiles. One is static, so you basically create all the tiles in advance. You store them on your hosting solution, could be S3 or whatever, and then you either have a small server or directly can fetch the tile from the client, and that's it. So you do all the pre-processing in advance to create those billions of small tiles. You put them on S3 and wait for the client to request the tiles. And the difference with dynamic tiling, it's you just host the data, the raw data, and then wait for the client to come and say, hey, give me a tile. And then the server will do all the steps, cutting the small piece of the data, applying reproduction, rescaling, or whatever math processes that you need to do on top of it. So instead of storing, making all this hard work of cutting the data, doing math processing on top of it, creating billions of data that sometimes when you have to update your tiles, you have to recreate all those things and to run your processes for hours and hours. And some of those tiles will never been loaded by the client because like they are in the middle of the ocean or whatever, and or like you don't really have client users for those specific parts of your data. So using dynamic tiling, you only render or create the tiles on demand. And so that's different ways. There are pros and cons for both, but I'm just going to talk about dynamic tiling because that's what I do for a living. And so, as I said, there are two different tiles, the raster and the vector. And today I'm going to talk and show two different projects. One called TiTiler, which works for raster tiling services, and the other it's TiPG, which create vector tiles. So first, raster and TiTiler. So a map tile is a square, and that follows, and the square is part of a grid called tile matrix sets. It's an OGC specification, so usually mostly all of us have heard about like the web Mercator grid, which was one of the default one for a long time on Google Map, and is still a default for a lot of web application. And so this web Mercator grid like follows a specification. It has a point of origin and a number of rows and columns. And so this grid like define like bounds for each tile, each smaller tile. And so we've developed a project called Morecantile that is used in all of our tiling projects that to define like the different tile matrix sets that you can use on the web app. And so what is Morecantile is just a Pydantic model that we created like reading the PDFs and the different schemas from the OGC consortium. And so Morecantile is really at the base of all the raster and the tiling services, because they define like what bounds tile index covers. And so, yeah, that's why I wanted to briefly talk about that. So just to trying to show some Python code, like the Morecantile project has different like default tile matrix sets that you can use, and for each matrix set, tile matrix set, you can get the bounding box of a specific grid of specific tile that you want. And so on the raster part now, so because it's dynamic, you need something to read the raw data. So when I'm talking about raw data, usually I'm talking about cloud optimized GeoTIFF because they are really nice. You can really fetch different parts like individually without loading the whole data in memory. And so for accessing those cloud optimized GeoTIFF, we use Rasterio and GDAL, and a small project that we built on top of it called RioTiler. So RioTiler will just enable you to open a file and get some information about a file, but or specifically like get like just read a tile from this data, and it will take care of like not reading the first not fetching all the data, but just the part it needs because it's a cloud optimized GeoTIFF usually, and also like taking care of like just making sure we don't request all the tiles, all the data around the tile, just like optimize the reading part of the data. So that's why the RioTiler is pretty fast, because like we are really making sure that we read only the part that we need when we are fetching a tile from the data set. And RioTiler has so it has some different readers. And so one reader for files like Cloud Optimized GeoTIFF, it also supports like NetCDF or HDF files using Xarray, and other like a small optional readers that we have added to RioTiler. And so yeah, that's the different readers that we can use. So I'm not sure if everyone knows about Stack, but Stack is like a metadata specification that allow you to specify metadata about like your geospatial data sets. And so there is this concept of you have a stack, which is an item, which is a feature, GeoJSON features, and that represent a place and a date in your data set. And then each items can have different assets, and the asset is just like a GeoJSON or like a geospatial dataset. And so with RioTiler, we have this stack reader where you give it the stack items that you want, and you just tell RioTiler to get information or to get a tile from a specific asset within the stack items. I'll show you example later why this is a kind of like interesting thing. It's also because like the stack reader it can open one file, but it can also open different files in parallel. So you don't really have to care about like how many files are going to be open, where they are. It's just transparent for you as a user when you are using RioTiler. And so there are other readers that you can also use to kind of mosaic files together. And so again, I could show you an example later. And so I talk about Morecantile, which is the way we define the grid. I talk about RioTiler, which is the part that read the data. And we use both projects within TiTiler basically we inject RioTiler readers and Morecantile within the TiTiler application, which is a FastAPI application that will create endpoints, so tile endpoints for our service. So yeah, I wanted to just to mention that TiTiler is just a wrapper on top of RioTiler, which itself is a wrapper on top of Raster, NGDAL, and Morecantile. So just to show you the flow between the dependency between TiTiler and RioTiler and other projects. So basically, TiTiler takes a RioTiler reader and create the endpoints, and by default, TiTiler can create a different set of endpoints, and you have also ways to specify what kind of endpoints you want and what you don't want, and you can also customize every endpoint as you want. So again, a bit more of Python code just to show you how you can create like a dynamic tiler yourself based on TiTiler project. So you import some modules, and like in a couple of lines of code, you can define those like set of endpoints that you can then deploy on the cloud or wherever you want, and you get a full set of like the endpoints for your dynamic tiler. So for example, for the tile endpoints, you give it like the XYZ, the tile matrix set ID, the XYZ NX, and the name of the file and the path of your file, and you can get the image tile back from that. Also, I wanted to show like that TiTiler is like really, you can really customize every part of TiTiler. As I say, you can choose to have some endpoints or not. But you can also, we use something in FastAPI called the dependency injections. So that's that part of like, that's for options that are defined dynamically when you call the endpoint, give it, depending on the parameters that you pass to the endpoints. And so TiTiler, you use a lot of those dependency injections, and also to really define what operation you can do on each endpoint to the files that you want to use. We have also the concept of like factories, endpoint factories. So it's like a class-based like endpoints or like a set of endpoints that we use. And you can expand like you can expand those factories, those class. That really customize your endpoints. So this is just an example of how the dataset, the dependency injection work for like the dataset, the path dependency or dataset dependency that you could set for TiTiler, saying that you only want to limit certain URLs that the endpoints can support. And this is a way to do it with simple Python code. So that's a full TiTiler application that will only accept 3 different images to be tiled, and by the way, by just like requesting the user to pass dataset equal B4, B3, or B2 to the endpoints. Yeah, so that's just showing how it look like then, because FastAPI is pretty nice. It creates like the open API documentation directly for you, and by changing the dependency, it also changed the open API documentation. So just a quick example of like how TiTiler works. So TiTiler works. So that's just a map. Every tile we see is being fetched like individually to the tile endpoint and like created on demand. So we just store the cloud optimized GeoTIFF. I mean, this image, like we don't store it ourselves. It's a public image store on S3, and so TiTiler will fetch every tile on demand by the client. So and it works pretty fast. And you can so one difference between the static and the dynamic way of creating tiles, it's static. In static tiling, you as a like data provider, you provide the data as you want. As you take the decision for the user. You decide how the data is going to look like to your users. Like the difference with dynamic tiling, it's the user that has all the power. It chooses how the data should look like to him, because he can decide what kind of band he wants to display, what's like the band combination. He can also play on the rescaling. He can like take really like the power of like making decision for himself if he's aware enough to for all these choice. But like at least he can, and at least as a like, data provider, or when you create the UI to access your data with dynamic tiling, you can like tell the user what it can do, what it can't do. But at least he had choice. You don't have to make the choice for him, for the users. So we were just seeing one image being tiled before, and this example is like a mosaic of like thousands of images to mosaic together with TiTiler. So the same, instead of having just one data, TiTiler can also work with like multiple files that span all over the world. And so this is natively supported by TiTiler by using some specific formats, but this is something that really is enabled by TiTiler. You can also have like different files, different ways of storing your data sets. And because we use Morecantile, we also also support different tile matrix sets. So you don't really have to use WebMercator for all your projects. You can also choose between the different tile matrix sets that Morecantile supports, and you can also add your own tile matrix sets, tile grid, to be used in TiTiler. It's really easy to install TiTiler. It depends on Raster, which provide wheels, Python wheels, so everyone can install it, and it's pretty fast to get going. So you just do pip install TiTiler core and application if you want the demo application, and use UVCon to launch the application yourself. So I'm sorry, I'm going fast, but that was the raster part. I can show you more examples later, but I want also to talk about the TiTiler TiPG, which is our tile server, a vector tile server. So instead of, like before, we were connecting the tiler to cloud optimized GeoTIFF or like raster dataset. Now for TiPG, we use PostgreSQL to store as a data source for vector tiler, so because it stores geometries and collections. And so yeah, TiPG connect to PostgreSQL to create those vector tiles. And we use like the st as MVT function from PostGIS to create those tiles. So there are many more projects that connect to Postgres to create vector tile. There is the MapLibre Martin project. There is also PG TileServe from Crunchy Data. They are all great, but like we wanted something in Python because encoded with FastAPI, so we could plug this application to other Python application that we had, and so that's why we decided to create this new project. And so TiPG doesn't just do tiles; it's also a feature API. that is defined by OGC. So we try to follow as much as we can the OGC specification, because usually our customers want that. So again, as for the Morecantile project, we had to read the OGC spec and translate the OGC spec to either Pydantic models or FastAPI routes. And I wanted to highlight one project that was really helpful for us. It's a data model code generator that can take YAML or JSON schema and translate that to Pydantic model. And it does really a good job, and it was really easy to get going with this small tool. So in TiTiler, we had this notion of reader to access the data, and so we have the same with TiPG. It's like a base class that define that it's an abstract base class that define that the collection should have like two functions. It should have get feature and get tile. And that will be, right now it's only connecting to PostgreSQL, but like if you add like you could like create this collection a collection object that connects like to GeoPython or to whatever data source that you wanted, if you that you wanted. And so it's just to highlight also that we designed TiPG to be extensible and like customizable, like to your own use case. And if you don't want to use Postgres, you can like use TiPG just to define the set of endpoints following the OGC specification without knowing the data source you use. And so yeah, this is just to highlight, to show an example that. So again, we use Factory, which is a class that create a set of endpoints, and so you inject some dependencies, and that will help the endpoints to know where the data and like the name of your collections and so on. So again, to create your own dynamic tile server using TiPG connecting to the Postgres database, it's just a couple line of codes that you can take the default application directly from TiPG and use it, or you can customize using the different options there are in the factories. And so I'm just showing how to create like a vector tile API, but like as I said, there is also the feature. The OGC feature API included in TiPG. So you have 3 different factories that create like a set of endpoints, the feature factory, the tile factory, and the endpoints, which is like combining both the OGC feature and the OGC tile API. And so again, you just do pip install TiPG and Unicorn, and you can launch the vector tile and feature API from it. Oh, wow. And I'm done.
Thank you, Vincent. Meanwhile, while we answer questions, is David already here? David Demashi? Ah, yeah, perfect. Okay. Maybe you can set up your device while we answer questions. Then we have a smooth transition. Any questions? No questions.
I'm just waiting to see.
I'll give you some more time. Don't be shy. Yeah.
Did you implement a caching layer for your endpoints?
So either in TiTiler or TiPG, we don't have a caching layer because we think that it's really easy for every user to implement their own caching layer on top of it. Usually we deployed, for our use case, we deployed TiTiler or TiPG in front of, behind CloudFront, so the caching comes from CloudFront. But using FastAPI, it's really easy to add a middleware to add the caching layer on top of that. So we don't really have to put the caching layer within TiTiler or TiPG, but it's possible.
Thank you. Any more questions?
Yeah, just to come back to this question, with your setup with Coctif on S3 that you read directly, does it even make sense to have caching here?
So you could, it's really interesting to have caching somewhere sometimes when you know that the user are going to request the same tiles over and over with the same the same styling. But then maybe it makes more sense to do static tiling for this kind of use case. So there is no good answer in my opinion to that. Do I have to put a caching layer on top of my tiler? Because it really depends on what the user will request. And still, TiTiler is slower than dynamic tiling is slower than static tiling. So if you think that your user cannot wait 500 milliseconds to get your tile, like you should use either like a static tiling or like put a caching layer on top of your dynamic tiler and just hope that the first user doesn't complain about the speed.
Any more questions? Okay, I don't see anyone else having a question. Then
Thank you.
Thank you very much, Vincent.
USB-C or HDMI?
Yeah, HDMI, yeah.